Today we are talking about 6.3, the basics of probability. These are the probability problems you probably learned at some point in your elementary journey, very basic ones. Thank you. So like if you roll a die, what are the chances that you'll roll a 3? Or if you draw a card, what's the chances you'll get this type of card? Those kinds of problems. A little bit of vocab first. Chances that an event will occur. Probability, chances that an event will occur out of all possible events that can occur. Just an FYI, if you don't have a calculator, please get a hold of one. Forgot to mention that. Need to get up and grab one, that's fine. I do have one more if someone needs it. An event, this is a term I've thrown around quite a bit, just threw it around now. It's just a single outcome within the sample space. Probability of an event, this is taking a notation and a formula approach to that term. First off, P of E, that's how we write probability of an event. You'll get used to that notation real quick. And how we find the probability of an event. The probability of an event is the size of the event over the total number of possible outcomes. Not that definition, no. This is just explaining what I'm doing. Once I do a few problems, it's not something you'll really think about. So the probability, it can either be a fraction, which most of the time, that's what your answers will be, a fraction. Or we can write it as a percentage, ranging from 0% to 100%. Or it can just be a number from 0 to 1, therefore most of the time it's a decimal. Let's do a very basic problem just to get us started. Determine the probability of rolling a 3 on a 6-sided die. We're using a 6-sided die, meaning there are 6 outcomes. And those 6 outcomes are the numbers 1 through 6. So 1, 2, 3, 4, 5, 6. And we want a 3. Of the number options, 3 only appears one time. So this is one outcome. We want the probability of 3, P of 3. And this represents P of probability of rolling a 3. This is just like a descriptive way of explaining what the 3 represents. Let's actually get to that probability. So the total number of possible outcomes, that goes on the bottom, so that was 6. And then on the top, what you want. We want to roll a 3. Now, a lot of students, just without thinking, put a 3 on top of here. No, there are not 3 3s. There's 1 3. So 1 out of 6 chance that we're going to get a 3 when we roll that die. Make sure you're careful about that. And there you have it. Let's do that with a frequency table. Use the frequency table below to answer the following questions. determine the probability of selecting an employee that is, first problem we're going to find is between 25 and 34 years old. So if we look at this chart, 25 to 34 is its own category. So that's the one we want. We want that 366. We're finding the probability of 25 to 34. To make our fraction, we have 25 to 34 on top, and then the total on the bottom. The top number we already know is 366. We do not know how many people are in this table. That's not given to us, but we can very easily find it. We just add all of these numbers together. And we will do this a lot. Most of the time when we give you a table, we will leave out one or multiple totals. Oh, I'm missing a number. Nope. You forgot something. I'm not sure what one. Nope. Add them all together, you will get 1,000. There we go. I had a feeling that was the one. So there's a total of 1,000 people in this table. We won't always do a nice number like that, so don't assume that's going to be the outcome. This would be your probability, but it is not reduced. You guys have calculators that can reduce fractions for you, so it is the expectation on a test or a quiz. If you have a fraction, if you don't reduce it, you will lose credit. To reduce, we use the ABC button. 366, ABC, 1,000. And it reduces down to 183 over 500. That's the fractional representation of our probability. Let's look at a couple others. We can also use the decimal. If you want the decimal, then you type this in with the division sign instead of the ABC. This tells your calculator you want a decimal answer. 0.366. So that's the decimal representation of this probability. And there's one more, and it's the percent. What's the trick to go from the decimal to the percentage without using your calculator? Yes. Yes. You take the decimal place and you move it over 2 times to the right. That will give you a percent. So our third representation, 36.6%. By the way, the SAT loves to ask you about moving from one to the other, so be prepared to get a question about that. We'll do that again with the new category. Our second group we want to answer for is no more than 44 years old. So let's break this down. No more than 44 years old. Does that include people who are 44 years old? I'll read it again. No more than 44 years old.
No, it does not include them. Like you can go 45 now, but no. But 44 people can get in the club. They can come in. Or not?
No more than 44.
Oh, so 40. Yeah, no, they can't come in.
Right. So 45 can't come in. Can 44 come in?
No. No.
We can't go more than 44. But we can.
Yes, they can come in.
Yes.
Okay.
So we're topping out, we're capping at 44. So this actually is, we could say this a few ways. We could say up to 44 years old, or we could say 44 and under. So I'm going to go with that one. I like that. So this is probability of 44 and under. That's why we clarify, because the wording can be vague. So we have 44 and under over the total. The total doesn't change. We still have 1,000 people in this table. Now this is going to comprise several categories. We go as young as 15, and then the 44 caps out at the third row. So all of these categories are included in that 44 and under category. So all three of those numbers, that's what we need. So we'll add those together. 54 plus 366 plus 233. Adding those together, we get 653 over 1,000. When you get a fraction, always check to see if it can be reduced. That's what the ABC button is for. 653, ABC 1,000. This time it gave me the exact same fraction that I put in. That means I can't reduce it. This is as far as it can go. This would be my probability. Let's go through the other two representations real quick. Or if we make that a decimal, it's 0.653. Or if we make that a percent, we move the decimal 2 times to the right, we get 65.3%. So those are the three answers. Questions over the table, the representations, fraction, decimal, percent. If you got that all down, you can move on to the next page. Next, we'll talk about independent and dependent probability. The words do kind of imply their own definitions. Independent events. The occurrence of one event does not affect the chances of the occurrence of the other event. So my first event does not affect the second one at all, doesn't change its probability. So we have a coin and a spinner. Me flipping this coin does not affect how the spinner lands. Those are completely different things. So they're independent. And the order I do them in won't matter either. Calculate each independent probability in simplest form. First we have the coin. That's 2 outcomes, heads and tails. And then we have the spinner. That's 6 outcomes. Numbers 1 through 6 on there. This is where you have to understand the notation, because this is how the probability will be written in short form. Number 1, probability of t, 6. What that means is the probability of getting tails, then landing on 6. So what we'll do is we'll find both of those, probability of tails and the probability of 6, and we'll just multiply those together. First, the tails. We have a coin that has 2 sides, and tails is one of those. So we have a 1/2 chance, 50-50 chance of getting tails. For the spinner, there are 6 total sections, 6 outcomes, and we want to land on 6. One of these numbers is a 6. So this is 1 out of 6. Multiply that with the calculator, please. Use the ABC button. 1 ABC2 times 1 ABC6. 1/12. I know I have some of you in here who like to multiply on the paper because you remember the rules. Please check your answer with the calculator afterward in case there's a mistake, in case you forget to reduce, whatever the reason. Number 2, probability of H, the probability of heads, and probability of getting an even number on this spinner. First, the coin. There are 2 sides and one of them is heads, so it's still 1/2. Spinner, there are 6 sections. How many of them are even? 3. 3 even numbers. 2, 4, 6. Half of them are even. Multiply in the calculator, it will reduce to 1/4. One more, number 3. Probability of H, probability of heads, and probability of less than 7 on the spinner. Probability of heads doesn't change. It's still the same thing as number 2. It's 1/2. Spinner, there are 6 sections. How many of those numbers on the spinner are less than 7? 6. All of them. So sometimes you will use your total number. Not often, but sometimes. Multiply those, it reduces to 1/2. Questions on the coin and the spinner? Number 4 and 5, they are very similar problems. There's one distinct difference between the two. They're still independent probability. If there are 6 green socks, 4 blue socks, and 2 red socks in a drawer, what is the probability that you randomly select a blue sock? So we want a blue sock. So basically, we're finding the probability of blue. Setting up our fraction, we want the number of blue socks over the total number of socks. There are 4 blue socks. That was given to us. And to get that total, of course, we'll need to add all of the socks that are in this drawer. There are 6 green, 4 blue, and 2 red. That gives us 12 socks. So it's 4/12. And we can use the calculator to reduce that to 1/3. Number 5 has the same information but asks a different question. If there are 6 green socks, 4 blue socks, and 2 red socks in a drawer, what is the probability that you do not select a blue sock? This is why it's really important that you read these problems carefully. That not changes the entire problem. And if you miss it, then obviously your answer will be wrong. The good news is, like I said, the numbers don't change from problem to problem, so we can cheat a little bit here. We're finding the probability of not blue. So it's the number of not blue over the total. We have 12 socks. If 4 of them are blue, then the other 8 are not blue. Use the calculator. That reduces to 2/3. Questions about socks before we move on to the next page? When you're ready, flip it over to the next slide. Talk about dependent probability. Dependent probability. One decision affects the next decision. They are connected. There's no way that you can separate the decisions. Two events are dependent when the outcome of the first event influences the outcome of the second event. Let's look at a marble example. Suppose you draw marbles from this jar one at a time without replacement. That detail makes it dependent. Give each probability as a fraction. When I take a marble out and I don't put it back, I'm now affecting the probability of any of the following draws from there. When you get a problem like this, we need to focus on the jar of marbles for a moment. You get a bit of information from here. Because we don't have any numbers, we have to go through and count these items. So my recommendation is first count the individual colors, add them up, get the total. That's what I'm going to do. Most of you only have a pencil to work with, so I'm going to do the same as what you would do. I'm going to use symbols to kind of label these in the jar to help me keep track of what I found. So for the red marbles, I'm going to circle them. We have 4 red marbles. For the blue, I'm just going to put a slash through them like that. We have 7 of those. You can choose another symbol to do the green, but honestly, the green is what's left untouched. So I'm going to leave that as is. So the untouched marbles, there are 5 of them. We have our individual numbers for each color, and of course we need the total. There are 16 total marbles. On a test or a quiz, I would encourage you to go back through and count the individual marbles and make sure you get 16 as a check on the math you've already done. If you don't get 16, count again or redo the counting of each colored marbles. Now we have the numbers we need to answer these problems. Number 6. P of RG. I want you to read that as P of red, then green. That then is key there. That means we're making these draws in a particular order. That order absolutely matters. So we'll first find the probability of a red, and then the probability of a green. We'll multiply them together. First, the red. This is the first choice. We have all the marbles on the jar. There are 16. Now again, we're putting down probability. What are the chances I'm going to get a red? I'm pulling out 1 red, but what are the chances I'm going to get a red? There are 4 red marbles, so I'm writing down all 4 of them. 4 red marbles out of 16, I'm going to pick up 1 of them. By the way, when I'm doing this, just for the sake of remembering how to do this problem, I'm not doing this with my eyes closed. I am going in and I'm pulling out these marbles because I want to make sure I get what I want. So I pulled out a red marble the first time. 1 marble is gone. We now have 15 marbles left in the jar. 1 red was taken out. So I still have all 5 green marbles left in there. Multiply. Using your calculator, we'll reduce it for you, 1/12. That's the chance of this happening. Number 7, P of R, R. Probability of getting a red and then another red. First draw, new problem. I now have 16 marbles again. 16, 4 of them are red. I'm going to grab a red out. Again, we're assuming this is happening. I go to make my next choice. I pulled a red marble out. I want another red marble. How many red marbles are left in the jar? How many? 3. Yes. Since I pulled one out that first time, that did affect the number of red marbles in the jar, not just the whole number of marbles. So now it's 3 out of 15. Multiply, reduce with your calculator, you get 1 out of 20. That's the probability of this event happening. So you have to keep track of your colors that you're using here. Number 8, we're going to do 3 draws. Probability of getting a green, and then a blue, and then another blue. I'll go ahead and do the denominators first since that pattern's very easy to see. First draw we have 16 marbles, second draw we have 15, third draw we have 14 left. Take away a marble each time. First draw I have all the greens available to draw from. There are 5 in there. First draw I pull out a green marble. Again, I'm doing this with my eyes open. I'm looking for that green to grab. Second draw I'm looking for a blue. I haven't taken a blue yet, so there are 7 of those. Third draw, I have a green and a blue in my hand. There is 1 blue missing, so I now have 6 to choose from for that second blue that I'm grabbing. Multiply all those together. Your calculator can handle 3 fractions just like it does 2. So we have 5 ABC 16 times 7 ABC 15 times 6 ABC 14. 1/16, that is the probability of this event occurring this way.